Hi, this is Alex from devstories.eu. OpenCV Computer Vision Deep Dive, Episode 5 of 20. Mobile document scan apps seem like complex AI magic. You point your phone at a piece of paper and instantly it flattens into a perfect digital document. But the core engine behind this is not a neural network predicting missing details. It is built on a 15-year-old math trick involving a 3x3 transformation matrix. This episode covers real-world geometry, building a document scanner. Think about a crumpled receipt lying on a restaurant table. You snap a photo from a slanted angle. Because of the perspective, the receipt looks like a skewed trapezoid surrounded by the texture of the table. To extract the document, the first step is isolating it from the background. You convert the image to grayscale and apply a slight blur. This softens the noisy details like the crinkles in the paper or the wood grain on the table while keeping the main boundaries intact. Then you run canny edge detection. This highlights the sharp intensity changes, leaving you with a bright outline of the receipt against a dark background. Next, you need to turn those loose edges into a defined shape. You find the contours in the edge map. The image will contain many contours, and most of them are useless small artifacts. You sort them by area, keeping only the largest ones. Then you iterate through these large contours and approximate their polygonal shape. You are looking for a specific structural clue. If you find a shape that can be approximated with exactly 4 points, you have found the boundary of your receipt. Those 4 points define the corners of your document in the original, angled photo. Now we reach the critical step of flattening the document. A common misconception is that this process uses artificial intelligence to guess or hallucinate missing data. It does not. A perspective transform is a pure mathematical warping of pixel coordinates from one plane to another. To execute this, you need 2 sets of 4 points. The first set is the 4 corners you just found on the receipt. The second set represents where those corners should be in the final perfect image. To get the second set, you calculate the maximum width and maximum height of the skewed receipt using the distance formula between the original points. You then define a new perfect rectangle starting at coordinate 0, 0, extending to that exact width and height. With these 2 sets of points, you calculate a perspective transformation matrix. This matrix defines exactly how much each pixel needs to shift, stretch, or compress to move from the slanted trapezoid shape to the flat rectangle shape. Finally, you apply this matrix to the original high-resolution image. The math literally pulls the 4 corners outward and squares them up, warping all the interior pixels along with them. The result is a perfectly top-down, 2-dimensional image of your receipt ready for processing. Here's the key insight. You do not need deep learning to correct perspective. As long as you can isolate 4 corners, a simple matrix operation will perfectly remap the geometry of any flat surface. Thanks for hanging out. Hope you picked up something new.